earthquake, Philippine cyclone was there, there was a partial PDNA again. And you can see that every sector has been accounted for. Next slide, please. See, we have the housing, we have the public building, damage to the heritage monuments, the roads, the urban infrastructure, rural water, every structure. You think of it, and there was it. Next slide, please. In this table again, you can see that the greater relief and assistance could be provided to the people. That is only because of the holistic nature of the PDNA that was being carried out. Next slide, please. Keep on pressing that button, forward button. This, the difference, where it lies, the difference. Please, one slide back. Yeah. These usually what we call are the relief memoranda. And they are like state authorities, and the numbers, as I initially mentioned, like we incorrectly call them damages and the losses. Next slide, please. Like in the Gujarat earthquake was there, and then there was the Bihar floods were there. Due to paucity of time, I'm not dwelling too much deep into it. Please make it fast. Next slide. See, this is the weakness of the existing system in our country. The population that is affected, not all of that is included. Some part or some sector is always missed out. The assessment concentrates only on the relief assessment part. We suppose if you have a car today that is of a value, say you purchased it a year back of rupees 2 lakhs, and today that car costs by the depreciation like say 1.5 lakhs. But if you lost that car and you are going to purchase the same car in the market, you have to spend 3 lakh rupees. The government will provide you only 1.5 lakh. But there lies the key. So we are focusing on the needs part. Next slide, please. So I'm not saying that the current situation or the setup that we are having today is flawed, but only what we need is the reinforcement of the current setup so that the people are not disgruntled and the person who is affected by the disaster gets the maximum amount of the relief. Next slide. Next slide. See how the PDNA what I can say like is going to be helpful because it is scientific, it is comprehensive analysis, it will focus on the recovery and the reconstruction, and it will ultimately lead to the build back better. That is also the concept of the Second World Congress. Next slide. And it will further lead to sustainable future. Next slide. Skip them, skip them. This is the situation, like how we are going to do the PDNA. We need the assessment teams for the PDNA, and then those teams need to be trained on how the methodology should be carried out. Then the sector-wise data should be collected. That data should be valid, that data should be verified, and then we should formulate a recovery strategy for that. Next slide. This is the way that how the operational steps are going to come. Next slide. I guess I have covered all those things, so I'm not reading them out. Next slide. See, this is the headlines of the newspaper, like rupees 5,000 crore lost in Jammu and Kashmir due to floods. Then Himachal Pradesh seeks 1972 crore for calamity relief. But there's no basis, like how people are asking for money. There was also reports of the corruption when the Uttarakhand disaster took place. So we need to quantify the losses so that we can provide the exact amount of money that is required. Next slide. So firstly, what we need is we need to define the terminologies and we need to be acquainted with them. What are they? The damages, the losses, the needs, impacts, recovery, and the reconstruction. Next part. Damage. Damage is usually that structure or the amount of the money that's said to be damaged, in which the recovery can be done in a period of less than a year. Next. Loss is like when that period extends beyond a year or when you cannot recover that thing at all. Next slide. Recovery are those things that are like the short-term needs for the people. Next. Reconstruction will be focusing on the longer-term needs. Next. 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 See, this is an example that I have included out here, in which you will get a better understanding like what will be categorized as the damage and what will be a loss. Say this is a building. Please, one slide back. Building cost for the repair was, say, $5,000. There was a computer in the building that was totally destroyed. Before the disaster, the shopkeeper or the person, say I, was earning $100 per day. And it was closed 5 days due to the disaster part. So, next slide. Next slide. Next slide. See. So the damage part is the $5,000 that I need. The computer replacement will today need $400, and my loss, that 5 days income of the money that is being completely lost, I cannot regain that. So that will be categorized as a loss. That is the $500. But actually what I need is a new computer. That new computer will cost me $1,200. The repair part, then again it is going to be of $5,000. And retrofitting, as we all know, the focus of PDNA is build back better, so that will again require additionally $500. So basically we are focusing that the government or the relief agency should be providing $6,700 instead of the $5,400 plus $500. Next slide. So basically this was the crux of PDNA. And I don't have time, otherwise I would have told you in much detail. But this is the need of the hour, because I think if that is accepted and that is being approved by the government, so the people will be like not feeling disgruntled. People will have faith in the government, and the government should be working in this regards. Thank you. Thanks a lot.
Thank you, Mr. Jha and Mr. Garg. Now the next speaker is Dr. K.M. Soni, and he'll be deliberating on seismic public cyclonic retrofitting of buildings. Over to Dr. Soni.
Good evening, everybody. I am K.M. Soni from CPWD, presently posted in Mumbai. Well, we have heard two beautiful lectures. One was on rehabilitation, repair and rehabilitation, and another post-disaster needs assessment. Probably we need pre-disaster needs also to be assessed because of our building we have seen in first lecture. So I will discuss basically seismic retrofitting of the buildings. And because our buildings are not really designed seismically proof buildings, so we'll probably need both the buildings, whether it is pre-disaster or post-disaster. Both type of buildings are to be seismically retrofitted. Can we start our presentation, please? We have seen that whenever we talk about the seismically retrofitted building or any retrofitted building, it is to be basically first it is to be repaired, then rehabilitated, and finally we are to do the retrofitting. When we call retrofitting, it means, and seismically retrofitting, we are calling that the buildings will be basically will be resistant to seismic loads. It means earthquakes. Let us have an idea what happened to the buildings, particularly in last 1 century, say 100 years. See, we always know, all engineers know that it's not the earthquake basically they kill the people, but it is the buildings or our structures we have built. And initially, you know, that chairman already told that it is we are the responsible for building, or maybe we may not, we engineers, or we are not. See, there are a large number of earthquakes every year they come, but it is few earthquakes which are really very, very dangerous to us, and all over the world probably earthquakes are coming. Next. But large number of casualties occur in developing countries, in India also, in developing countries. Why? Probably my idea is maybe inadequate designs, poor construction and maintenance. Maintenance also, we don't maintain the buildings. Lack of resources. We may talk about the US or Japan or anything, but we don't have so much resources. Inadequate knowledge. Knowledge has not really percolated to the down below, whether it is panchayat level or gram level or say block level, inadequate awareness. We are not aware, yes, chalta hai, everything. Say I have constructed some building with the RCC, then it will be safe. Inadequate training, we are not having adequate training for our engineers, whether we are working in interior or even in some part of the cities. Inadequate safety implementation, we are not that much for the safety of the buildings. Next. See, let us see how the earthquakes have damaged in last 1 century. See, this is Haiti's earthquake of 2010, where number of deaths, number of casualties were more than 3 lakhs. Next. This China of 7.5 magnitude, more than 2,40,000 deaths. Next. Sumatra, more than 2 lakhs again. See the buildings. China again, see the buildings. More deaths, more than 2 lakhs. See the buildings of Japan in 1923. After 23, the casualties are not even hundreds. But then they have developed themselves. See Pakistan, more than 86,000. See the buildings. Iran, again see the nature of the buildings, most of the buildings. Again our Gujarat, where we heard about 20,000 deaths. Then Latur, most of the buildings. Nepal, recent earthquake of the Nepal, over 5,000 deaths. See the buildings. Again Nepal. See Afghanistan earthquake. See the buildings. What may be the causes of failure of masonry buildings? Most of the buildings are masonry buildings, maybe brick masonry or stone masonry. See, also RCC buildings are also falling. They are also damaged during earthquakes. But probably they are designed by the structural designers mostly. But most of the buildings which are masonry load-bearing structures, they are not designed. So that is the difference. Next. Causes of failure of RCC buildings. Next, please. See, RCC buildings, if you analyze, this may be soft story is there, poor derailing of beam connection or column connection is there at the junctions, provision of floating columns has been done, inadequate foundation has been done, ponding of buildings is there, inadequate connectivity is there with the staircase or water tanks. All those are documented. You see, this building, poor detailing, poor connections, this building again, columns, poor connections of the staircase, soft story failure, again soft story failure, inadequate foundation, floating columns. But again, now these buildings, RCC buildings, mostly now they are designed. What happens to masonry buildings? Rehabilitation methods we have seen. RCC structures, they are going, we appoint the consultant. Because so he will tell you the plate bonding is required, fiber wrapping is required, or carbon fiber is required, or glass fiber is required, or jacketing will be done. So this structure or structural designer tell us. But in masonry structures, see the buildings. Now these buildings are of the capital, national capital of Delhi. Next, soft story, inadequate foundation, floating columns. So these structures are repaired by the structural designer afterwards. Next. See, depends how we do go. We see the cost, we see the technical requirement, we see the availability, all those things we know. Next. Now, retrofitting, you have seen. Next. Now come to the masonry buildings. Now these buildings are photographs of the Delhi national capital. See the buildings, how they are being constructed even today. See, there's no plinth band, there's no lintel band, there's no corner reinforcement, buildings are falling, even today. Next. See these buildings, new buildings are being constructed in Delhi. So this position is all over India. It means even today, we are constructed the buildings which are not according to the codes, they are non-engineered buildings. So what will happen during the disasters? We are hoping that let disaster come and then they will fall. Next. See, cantilever failing. Next. See, there is no corner reinforcement, there is no lintel band. Next. Here also you see on the top, there is no gable end. So what to be done? Now, we are to do the seismic retrofitting. In these buildings, can we do it? Whether it is possible that we make these buildings safe. That is the requirement of today. We cannot pull down all these buildings. We are to make them seismically safe. So that is called seismic retrofitting. Next. Codes are available. My friends, codes are available for RCC buildings, for masonry buildings. Indian codes are available. We can do that. Next. What is the requirement? If we do our new buildings, that for the masonry buildings, we provide plinth band, we provide lintel band, we provide RCC slab or roof band, if say in certain conditions with the cement mortar, and then we have restricted opening. This is given in the course. Now, what will we do in seismic retrofitting? Next. What are the materials required? Very simple. It is only cement and steel and some admixtures, as Mr. Sarma has told, that some polymer mixed mixtures or something like that, hardener or resin, etc. Otherwise, basically, this is steel and cement. What engineers do, that's all. Next. See, these are the chemical anchors. You can see on the left side. And this is washer, this is GI wire mesh. This is what is required, and cement and some resins. And then we can do the seismic retrofitting of the buildings. Next. Now, repair and rehabilitation is to be done first, because when you do any seismic retrofitting, first is repair and rehabilitation. Next. So, say this case study, some repair is required. So what we have done, that polymer modified mortars are there, they have been taken, and then the cracks have been filled up, and this has been done. So first is repair and rehabilitation work. Next. Now what is to be done in seismic retrofitting? You see, we cannot cut the space for the plinth band or lintel band or any band. So we cannot provide inside anything. What is we are to do? It is something like belt, what we put on our trouser. From outside, we put the trouser, so trouser doesn't go down. So similar, we provide a belts in the buildings. This is called belts. So what we will be doing, in place of bands, we will be providing the belts. So this is horizontal seismic belt, because if I am providing horizontally, this is a horizontal seismic belt. If I am providing vertically, this will be called vertical seismic belt. Now, horizontal seismic belt are to be provided on all walls, on both the faces, because from one side we are providing, from other side also we need it. So on both the faces and wherever we require. If we require at lintel level, we have to provide at lintel level. If we are to provide at roof level, there is no roof connectivity, then roof level. If RCC slab is not there, if it is plinth height is more than at plinth level, yes, we provide at the plinth level. And then next, like this. Pehle chaliye. See, this is. So on the wall, above the lintel, see, when we are engineers, we know, say, some already lintel is there, we need not to cut the lintel. Just above the lintel, you provide lintel band. And see that it is a monolithic construction. Next. See, this is case study. You will see this, how does it look now after we do seismic retrofitting. You can see on the top, there is a lintel band which has been lintel belt. So it is not the horizontal seismic belt that has been provided, and that has been plastered with micro concreting and plaster. Next. The category of the buildings, you have to take the gauge of the wire, that GI wire mesh, and then accordingly you have to provide. Next. Now this is around the opening. Another requirement of seismic construction is we have to provide seismic around the opening, we have to provide the reinforcement. So this reinforcement is provided, that is as per the code, you can see on the left. On the right side, that is actually provided GI wire mesh. Next. This is after plaster. Next. Then again, after plaster, you can see another bungalow from inside. Now, vertical seismic belt are to be provided when construction is there, we provide inside that. But after construction, when we are doing seismic retrofitting, we have to provide from inside also and from outside also. So how will we provide? Next. This is how it is provided. Left side, see, from the outside, I am providing GI wire mesh. So that is the external vertical reinforcement, vertical seismic belt, and you can see actually being provided. Next. Now this is, you can see how it has been provided on all the corners. Next. Again. And then again another bungalow. Next. from inside. From inside also we have to provide vertical reinforcement. Now vertical reinforcement can be provided. If you see the code that says that you can provide GI wire mesh or single vertical bar. Vertical bar has been provided, and here this anchoring has been done. Though code says, you can see on the left side figure, they say that you can have the, you can cut down the something brickwork and do it, but it is better not to cut down the brickwork, but you provide the anchoring. Next. Inside, after doing the finishing, what is to be done? After doing, you plaster it with the micro concrete or with the plaster, this plaster. Next. This is, see, in my case, jack arch roofing was, segmental arch roofing was there. So those arches are also needed to be interconnected, because otherwise there will be no monolithic action. So this has been interconnected by flats. Next. Now anchoring is important. See, you cannot put all the GI wire mesh, everything just like that. Not by the nailing, please. You have to anchor it. This whole thing what we are providing must act in monolithic construction way. So you have to anchor it. There are two types of anchor we know. One is mechanical anchors, second is chemical anchors. In brickwork, if you provide mechanical anchors, then bricks, because being not of that strength, that material clay comes up, and then you will not be integrated. What is to be done? You provide chemical anchors. In chemical anchors, you can see these are the anchors which are there, and this is the washer simply made from the MS flat. This is how it is to be done. See, wire mesh is there. You put a hole, you drill a hole, the drilling machine, clean it. After cleaning, there is a hardener and resin available. You put hardener and resin in this one, put anchor, and then after that you provide the washer from top side. Next. This is anchoring. You can do the anchoring, provide washer, and anchoring can be done. So it doesn't come out. In any case, it will not come out. Next. These are the specifications already given in the code. You can follow as per the length of the wall, as per the openings, everything you will see, and as per the importance of the building, and which category of the building, in which zone it is there, that is given. You can follow the specifications. Next. This is the after that. You can see on the top, the roof band has been provided. You can see lintel belt has been provided. Horizontal belts at the roof level, at the lintel level, and you see around the opening, at the corners, these all things have been provided in the bungalow. Next. This is from the interior. Next. Next. Again, another bungalow. This, you can see overall how it is look after doing the work. See, we can do, in place of GI wire mesh, we can do carbon fibers, we can do glass fibers, then these bands do not appear on that, because thickness of fiber that is less, so, but they are costly. This is simple. This is not that much costly. Cost hardly comes about between 6% or 7% of the cost of reconstruction of the building. Next. This bungalow, you can see. Next. Again from internal, because this is vertical reinforcement provided from inside. Next. Again, another same thing. Next. Now some additional steps have been given, what precautions are to be taken. Basically precautions are to be taken so that it does not corrode again, and it has anchored properly in the structure. So these have been given by me, but because of the time, I will just skip these steps. Again, I will skip some requirements. Next. Next. Chemical anchoring, I am saying, should be done in brickwork. You can do mechanical anchor in RCC. Now, training, as I told initially, training, upgradation, and competence building is required. This is simple techniques. This can be given at engineers, junior engineer level, assistant engineer level, at panchayat level, district level, even. This can be done in easy handouts, and even mason, after doing certain works, mason will understand what is to be done. And now then, at the large level, in our country, we can do the seismic retrofitting of such buildings which are not safe. So, like Swachh Bharat Abhiyan, we are talking, maybe that someday we talk about these buildings also to make safe. Next. Next, please. Now, training is to be given to all policy makers, administrators, because they are to be, particularly they should be agree that it is to be done. When we did the work, we prepared the items, what is to be done for engineering community particularly, what are the items comes with the analysis, so that we did for our purpose also, and they are available with me. Next, please, next. So these items, because you know that in schedule of rates, they were not available. So they were all analyzed items, and we analyzed. Thank you very much for the patience hearing.
Thank you, Dr. Soni, for making it known to the people how the precaution how the pre-disaster efforts can reduce the post-disaster management requirement reduced. And now I will request Shailendra Sharma to take up the precautions required in the building construction in earthquake and cyclone prone area. Again, to mitigate the disaster, not to manage the disaster.
As we have discussed so far, what we are focusing in this session is on disaster mitigation rather than disaster management, because as you know, prevention is better than cure. India today is on its track to development. Lot of investments are being made by all of you individually in your houses, by the industry in the infrastructure, and unless we take proper precaution, these investments are at risk. If we know right in the beginning what is to be done, probably by adding a little bit of cost to the extent of 5% or so, even less maybe, we can prevent a major damage later on, which will prevent damage to the property, damage to our life. That should be our intention. I'll tell you of a personal experience. I had the occasion of doing a MS in Japan, and while I had been in India, the concept we had been taught as children was that if there is an earthquake, just run out of the building into the open fields. They are safe. The first day I landed in Japan, we were given a briefing, and the first thing we were told were, do not run out of the building. Their buildings are so well designed, they are sure they won't fail. They say, they tell you so many other things, but yes, you take refuge under a big furniture, heavy furniture. Don't rush out of the building. That is the first thing they are told. That is a level of confidence. So we hope to reach that level of confidence. That should be our aim. First of all, I'll deal with wind cyclone resistance of buildings, because that is more relevant to to Visakhapatnam. Last year we have had Hudud cyclone. Every few years we are having. So next slide, please. So this is the action of wind forces on a building. The wind acts on the facade. Their load is transferred to the slab, and that in turn is taken by the walls and transferred to the ground. Why this is important, I'll show later, because these days there is a lot of, it has become fashionable to provide glass facades. And the danger they pose to the building and its perimeter, that is not understood by everybody. Next, please. This is the wind load map given in Indian Standard Code, and the red color shows high wind speed, design wind speed, as provided in the map, and we are in that zone. Next. There are different methods of design of structure, which I will not go into detail because not all of us are engineers here. Next, please. But in short, the wind load which is taken for design of a building, it depends on the risk level of the structure being designed, whether it is very important like a hospital or a school or such building, or just some routine building. It also depends on how densely constructed the area is, the height and size of the structure, and the local topography. That is whether it is right on top of a hill or in a valley, because that determines the wind speed it will suffer. Next. Yeah. So I showed you a wind load map. From that, by applying these factors, we can arrive at the design wind speed. There is a relationship as I am showing. Next. From the wind speed then, the pressure on the building facade for which it has to be designed can be calculated, and that is how we can design the buildings. Next. Now, particularly dynamically sensitive structures such as transmission line towers, chimney stacks, steel water tanks should be designed following dynamic design procedure. All this is provided in the code. When it is not done, we have damages like this. These are photographs from Hudhud only. Next. There is a wind and cyclone hazard map today available, which shows the hazard potential of various parts of the country, and you can see it is more or less, it is coterminous with the wind map given in the code as earlier. So some points conceptually I would like to point out, which are of interest, which should be of interest to everybody. So the planning for better wind resistance starts from the site selection. If you can, don't locate your building on top of a ridge. Top of a ridge invites highest wind velocity. If possible, locate them in valleys where the wind velocity is less and there is protection. Next. Next. Also, storm tides accompany cyclonic storms. When close to coast, if you are making a building close to coast, try to choose a site which is above the likely inundation level. As you can see in the graphic there, with cyclone comes high tides and then submergence is possible. If you can't avoid building close to coast, then construct on stilts and provide knee braces so that, and knee braces allow the water and debris to pass below, and the building will not be damaged that way. Next. This is the flood hazard map of India. It will give you the broad idea of where flooding is more likely to take place. Of course, you have to, when you go for a building, you will have to take the local factors into account. Broad guidelines can be taken from this also. Next. Yeah, building configuration. This is very important. As can be expected, in any building, if the building is symmetric, it is circular or polygonal, it will have much better resistance in all directions and will be able to withstand wind from all directions. If it is having lot of voids and spaces which will catch wind, it will carry more wind and it will suffer more damage. Next. I'll show, this is an example of the Doppler weather radar on top of Kailashagiri hills. All of you know who are from this Visakhapatnam. This is right on sea coast on top of a ridge, which I said catches maximum wind. And this is the Doppler weather radar of India Meteorological Department. We maintain that building. As you can see on the left lower side, the wind was so strong that all the leaves have been stripped off the vegetation and the trees. But if you see the building, this is a circular building, symmetric, and it has really not suffered much of a damage. Only 2 windows which you can see in the front, they have been blown off. And some architectural glass we had provided on the top floor, which is gone totally, of course, here on the top floor. Otherwise, the rest of the building is quite fine. We were able to put it back in operation very quickly. Now, what are the vulnerable areas in roofing of a building? The areas shown in bands near the edges and the ridges at the top, they suffer maximum wind uplift and they require special care. If any openings are there, large openings on one side of the building, they may further allow wind to push from below, which creates positive pressure, and then the entire roof may be further lifted. It may be noted that such an opening can be created in the process of cyclone blowing away a door or window or a glass. So we have to make buildings such that this should not be a possibility. I'll show you some more photographs about this later on. Next, please. This is a photograph of special economic zone. These sheds, large industrial sheds. Note that most of the damage has taken place towards the gable end and at the top of the roof. That is the normal pattern of failure in roofs. Next. Again, if you see closely, this rolling shutter was totally blown off because of the strong wind. The shutter size is large and the slats have been blown to smithereens actually, and that has added to the uplift from inside, and therefore this damage has taken place. Next. Again, same thing. So you see that the damage is more towards the gable end and near the top, and where there are openings. Next. So this is the general pattern of wind flow and where the maximum uplift takes place. If there are large overhangs, they tend to uplift. If, towards the edges and towards the ridge, the uplift is maximum. And if there is a opening, then there is a possibility of further air pressure adding to that uplift. So as a result, these are the types of failures which occur. Either the sheet can be lifted up, or the purlin can be lifted up, or the roofing at the gable end, particularly as I showed in the previous photographs, gets lifted, or if there is not proper connection, the entire truss system also can get lifted up. So the most important thing is connecting all these various elements of an industrial roof to each other, so that local damage does not take place and therefore the entire thing is not destroyed. Next. So one recommendation for cyclone areas is, normally those who are aware of the construction process, we use a J hook for tying down the sheet to the purlin. So instead of that, it is a good practice to use U hooks in cyclone areas. Next. Otherwise, we should reduce the spacing of J bolts, and also as an additional measure, we should provide steel strap along the edges and the ridges. Because what happens when the wind is very high and gust is taking place, the entire sheet flutters and is lifted, and local punching of sheet through the bolt takes place. So all that can be prevented with this. Next. The roof truss in turn should be properly anchored with anchor bolts and base plate in the masonry or RCC lintel band below. Purlins should be properly anchored at the gable end. These are the points where failures often take place. Next. Roof bracings should be provided in industrial buildings. This is a standard practice, should be done. If it is not done, of course, it reduces the stiffness of the entire system and the failures can take place. Next. Again, bracings to be provided at column level also, at eaves level also. Next. Now coming to glass paneling. As I said earlier, one of the most damaging effects of strong winds is seen in extensive failure of glass panes due to high local wind pressure or damage due to debris. The broken glass further increases internal pressure abnormally. Next. So, all of us remembered photographs from the airport damage last year in Hudhud. I am quite sure a large part of it was due to this. This photograph on the left side, this shows the glass curtain wall totally blown away. On the tarmac side, there is no glass there. And of course, on the right side, photograph is of the damaged roof sheeting. Next. Another photograph, and as you can see, the entire roofing of the airport has been blown away. Next. So what are the lessons to learn? That damage has taken place, and today I can see it has all been repaired also. The point to understand is, in cyclone-prone areas, slope of pitched roof should be in the range of 22 to 30 degrees. That is the optimum range in which uplift pressure is minimum due to aerofoil effect. As you can see today also, the design of the structure is such that in places it is less than that, and therefore it is going to experience very high pressures, uplift pressures. Secondly, large openings in glass facades can again be damaged, and again the same kind of damage can take place because it would create additional positive pressures. Next. Another similar building, glass building, totally blown away. And as you see, large projections in the roof, they have also been damaged. Normally the projection should not be more than 500 mm, which is required for rain. But for architectural reasons, people are providing these days, and they are damaged, as can be seen here. So use smaller panels of glass, strengthen glass by using sandwich polyvinyl butyl films, provide metallic mesh or some kind of protection outside glass to prevent against debris impact, and provide strong locking arrangement of doors and window shutters. The frames also should be securely fixed to the walls. Next, please. Next. This is another photograph of a passport office building. As you can see, only minor damage to the cladding is there. Then this was quickly repaired. Next. If foundations themselves are not deep enough and strong enough, they can be lifted up. And one should keep in mind that there can be a tidal surge up to 10 to 15 kilometer inshore when scour can take place and soil capacity may be reduced. Next. Power supply, to the extent possible, should be underground because it reduces load due to falling branches or wind. Otherwise, foundation block should extend high enough above ground so that natural frequency of the pole is less than 1.5 hertz. Otherwise, damage like this become extensive. Next. Protection works should be provided to raise ground. Next. Strengthening of masonry walls, this has already been discussed by Dr. K.M. Soni, can be done in various ways, so I will skip this part. Next. So, summarizing, site selection, proper building configuration, proper design, proper building material, bracing in steel structure, RCC bands in masonry, strong connections, especially near the edges, and strong and well-anchored foundations are important for wind load. Actually, I have to speak also on earthquake, but my time is more or less over. I will very quickly stress upon the most important point. Please, the next earthquake, so that the most important thing is not missed. The rest has already been covered by my other speakers. The structure, this is the performance criteria for earthquake resistant design. What many people don't know is that there is no earthquake proof structure. It cannot be economically done, except of course if it is a nuclear reactor or some such extremely important structure for which we can invest any kind of money, because in case of disaster of that kind, the results can be unimaginable. So leaving that apart, rest of the buildings cannot be designed to withstand the highest magnitude earthquake. The buildings are normally designed so that they should be able to withstand minor earthquakes without any damage, moderate earthquake with some structural damage, and in case of major earthquakes, it should not fail. It should have a no collapse design. Next. So this is done by providing ductility to the building, and ductility is the ability of the building to bend, sway and deform without collapsing. Next. In case ductility is not there, the material is brittle, the design is not proper, lot of failure takes place. Next, please. If you notice, the columns in these buildings are very small sized. They have failed at the junction, and that is why this collapse has taken place. The Indian Standard Code specifies column width should not be less than 30 centimeter. That's less than that. And a lot of our architect friends, they try to provide 9 inches to 230 mm thick columns. This is a result of that. Next. Another pancake type failure. Next. So there are 3 basic principles. Strong column, weak beam. The beams should be comparatively weaker than the column. Column should not fail first. That is a fundamental requirement. Number 2, failure of beam column joints should be prevented. And number 3, the failure should take place in bending only, a ductile mode of failure, not in shear. So next, please. So it has been proven that this ductility can be provided if we can confine the concrete by providing steel stirrups. Next. This is a curve. Yeah, previous one, please. Yeah. So if you see, the lowest curve is unconfined concrete, which is just the concrete. And as we go on adding steel reinforcement with ties, the curve goes up. The strength as well as its capacity to take more strain increases. It can take a lot of vibration under the earthquake. So this is one message I would like to give, that we should follow the details. Next, as given in IS 13920. Next, please. Next. Next. So we should follow the ductile detailing as prescribed in IS 13920, and if we do only that much, that will be good enough for making our structures strong for withstanding most of the earthquakes. I will curtail my presentation here because time is short. Thank you very much.
Thank you, Mr. Sharma, for covering wind as well as seismic design and detailing and precautions to be taken. I'll request Mr. D. Roy Chaudhary to take up the construction of disaster resilient roads in landslide prone areas.
Some of you also might be wondering why this person from CPWD is telling about roads and landslides and all that. Just as a backgrounder, I would like to inform that CPWD has a border fencing and road cell, and we work to provide border infrastructure for the country on all our international borders. And amongst them, the Indo-Bangladesh border on the northeastern side, and the Indo-China border. These are the areas where a lot of landslide prone roads, roads which are passing through landslide prone areas have to be built. And my presentation today, my talk would focus on the ways to mitigate, especially the new technologies that we are looking at. Next slide, please. We are providing engineering resources to MHA. And if you see the northeastern states and Uttarakhand, these are the places where we have landslide prone areas, and these are the places that I will be dealing with in this talk. Hill road construction, of course, is the basic work that takes place in this area. In the next phase, we are going to take up roads in Kashmir, Himachal Pradesh and Arunachal Pradesh also. We are also looking at new technology in terms of better alignment, better drainage, and better slide and fall protection. Next, please. Just for those who are not initiated into this area of work, I have in 2 slides I have tried to of landslides, its definition and classification. In very simple terms, landslides are defined as downward and outward movement of soil or rock or a mixture of both under its own weight. It occurs always under its own weight. These are the basic different types of slides. One you can say is a translational. Another one is slow creep. This is also very much evident in the case of glacial slides, where the material creeps down very slowly. There is some rotational. The one that I have shown here as fall is also very important in case of mountains meeting the sea, where the wave action breaks away slowly the part of the mountains, and such type of falls may be very relevant on our eastern and western Ghats. The actual movements what we find are most often a combination of all these. Next, please. These are the types of landslides. They have been given by DJ Wands, and the type has two words. That is, one defines the material and the second defines the type of movement. So on the left hand side you can see falls, topples, slides, and the type of material could be rock. It could be soil, where you have mostly coarse or small pebbles and boulders, and it could be fines also, where we call it earth slide. And predominantly coarse one is called debris. And in again, the most commonly found landslides are a complex type which has components of all of these. Next, please. Here we go with the causes of landslides. This is again, slightly on the technical side, but please focus on the human causes, where we have excavation, loading of the slope or its crest. Especially when we do road construction, we try to put the cutaway material onto an existing slope, and we may be triggering landslides because of that. Artificial vibrations of our road building machines, irrigation, mining, and leakage from utilities. So these are the basic triggering mechanisms for slides. And when I say slide, I also mean slides as well as falls. Normally we call it a landslide event, which includes slides, falls, topples, also all types of movements. Disaster potential of landslides, most of us are aware, and especially in South India, in the Nilgiris, there is a lot of landslide areas where the landslide hazard is more. 15% of the land area in India is prone to various degrees of landslide hazard. The states that I have mentioned, J&K, Himachal, Uttarakhand, we all know that. Landslide causes around 500 human fatalities and 300 crores of property loss in terms of monetary terms, 300 crores annually. We also know that earthquakes and floods, these trigger landslides, and when that happens, the disaster potential is multiplied. You have a disaster which is an earthquake, and on top of that, it creates a situation where subsequently you will continue to have slides over a period of time. This situation we faced when we were constructing roads in North Sikkim in 2011, after the 2011 earthquake. Right up to the end of 2012, we continued to have frequent slides here and there of small or large magnitude. Next. These are some pictorial examples of the severity and the expanse of landslides that happen. Next. Now, I will dwell on this slide a little bit. Let me assure you that I have only 20 slides, so there is not much to tell you. But yes, I will dwell on this slide a little bit. Most often what happens is the agencies that do the road construction, and we know that in the landslide prone areas of Northeast, BRO is one agency which has been doing work, CPWD has been doing work. In these areas, the agencies which do the road work, they do not have the mandate of landslide protection and rockfall protection and all that stuff. So that is something which has to be looked into, because these are the people who are doing the triggering of the slides, most of the technologically late movers. Most of the roads, etc., which are constructed in the hilly regions, they are government works. And you will all appreciate that government is a technologically late mover. We wait for the technology to establish itself, and then we try to adopt the technology which is time tested and which we know that will work. So there is very little risk taking in government. So here also we are technologically late movers. There are technologies which are available which can lead to more resilient roads, but we are yet to use them. We will be looking at some of those technologies. Monitoring and prediction of landslide is not prevalent. Even at locations where the landslide hazard is known, there is a landslide hazard map. And even in those areas, we do not have you can say the funding, or the prioritization is such that we are not doing much monitoring. And especially after earthquake, the hazard zoning changes, which again happened in Sikkim. The areas which were not so landslide prone started showing landslides. And some of the areas which were thought to be landslide prone, they did not show much of the slides. The road construction agencies have neither the budget nor the mandate for this type of work. Next, please. Then there is the question of capacity. How to, because we have not been doing, so we do not have much experience in how to deal with road sector in the landslide prone areas. Just we keep on cutting, and if there is a slide falling onto the road, we will push it down the valley. If the road itself goes away, then we will cut some more into the hill and make another new road. So the capacity to deal with such things, and whatever technology is available is again vendor driven. So there again is a major problem, because if the vendor is providing you the specification, then there is a fear that there may be overkill, or the vendor may be trying to sell his own products to a much larger extent than what is required. Insufficient and piecemeal stability measures often turn out to be ineffective. And then the decision makers will then have a tendency to say, no, this technology does not work. Most often, the technology in its completeness is not adopted because of budgetary constraints, and then we end up blaming the technology. Because of insufficient capacity, insufficient knowledge about the technology, we may not be able to know what is the minimum amount of intervention that is required to be done. Work schedules are often tight and obviates the possibility of in-depth studies and technically innovative interventions. And unauthorized excavation, unauthorized jungle clearance, these are activities which also create situations that will trigger landslides. Next. Improvement of road construction techniques to mitigate landslide hazards. There are basically two types. One is the non-structural, which is non-engineering part, and other is the structural or the engineering interventions. In the non-engineering, you can see roadside warning signages, identification and mapping of hazardous areas, budgeting for interventions in hazard-prone areas. These are the non-structural things. Next, please. In the structural, we have this modification of slope geometry. Although this is very effective, but it also leads to a creation of lot of debris. It is like we are removing the landslide before it happens. The problem is it is environmentally not very friendly, and you need to dispose of a large amount of debris somewhere in a very ecologically sensitive area. Retaining structures, this is all different types of structures. Engineering, again, I will not dwell upon it much. Next, please. Again, internal slope reinforcement is one option within which we have different types of technologies for different types of material, different for rocks and soils and such. Improvement of drainage, this is a most important thing. People who have lived in the hills, they will appreciate that drainage of water from the hillsides is the most important criteria for maintaining your hill roads. And those who have been to Sikkim and Kashmir, they know that most of our roads won't survive beyond 2 to 3 seasons. And most of the time it is because our drainage is poor. Rockfall protection measures are there. I will show you some slides on that. Next, please. As I told you, we are engaged in construction of strategic roads in the border. We